Here is the general form of a binary logistic regression. Of course, all these calculations will be handled by computer, and it will give us a very neat and clean table, and then you can use ChatGPT to interpret all these tables. But the purpose of explaining these general form over here is that we understand the mechanics behind the calculations and reaching to those kinds of conclusions. So number one, we know what is going on behind the scenes. And number two, we can fully comprehend the interpretations of all those numbers. The equation which you see on your screen is very similar to the one which we saw for the linear regression. The only difference being that we are first converting it into the log here. The most important value over here is, of course, the probability of the event. That's the hero of the movie here. We are trying to determine if disease will happen or not. For example, if cancer will occur in, say, the people who are consuming asbestos, for example, over a period of time, or maybe we are trying to see if our drug will have an effect on the disease or not. If COVID-19 vaccine, what is the probability of COVID-19 vaccine to decrease the occurrence of COVID-19? What is the survival? What is the probability of a person surviving 5 years from now from, say, stage 4, certain kind of a breast cancer? But the thing is that since the probabilities are normally bound between 0 and 1, we cannot really run regressions because of all the challenges that we discussed in our previous video. So what we are doing here is that we are converting those probabilities into log odds. So they becomes unbounded, and they are now extending from negative infinity all the way to positive infinity. And then it enables us to run the linear modeling. The right hand side of the equation is very similar to the linear regression. Beta naught over here also represents the odds of event when all the predictors are 0. The only change here is that it is the log odds, not the odds itself. Not the beta naught is anyway a theoretical value, but over here it will not be interpretable in the way we did it in linear regression. But here is the good news. The system will also give you the inverse of log odds, the actual odds. That is very much interpretable, as we will see in the next few slides. And then practically we'll do it in the next video. Beta naught, again, is the most important value for the probability. It is the slope or the coefficient indicating the change in log odds of the event. For the continuous predictor, it will be the log odds of log odd change per unit increase. For example, if it was cholesterol, so we will get as a slope, we will get how much change in log odds will happen when each unit increase in cholesterol. Categorical, if our coefficient, if our variable is a categorical predictor, then it will be the value in relation to the reference category. For example, if our reference category is female, it will give us the value for the males. If our reference category was, say high BMI, obese patient, then it will be the value for the normal BMI individuals and so on. You will understand more when we'll do it by hand, and we will explain it, of course, by an example in the next few slides. The X value here is the presence or absence of the independent variable. Suppose we are interested in measuring the probability of chronic heart disease based on these three predictors: cholesterol level, sex, and age. In that case, our beta naught will be the log odds of chronic heart disease when all the predictors are at the baseline. That is, cholesterol is 0, the reference value is female, and age is 0. So the way we interpret is that the beta naught will give us the value of a female of age 0 and cholesterol 0. Of course, again, this is a theoretical number which do not have any practical or clinical value, but it gives us the starting point. The system will give us both the values. One, the log odds, which is at least humanly not interpretable, but it will also give us the inverse, that is the odds, the actual odds. So it will first convert it into to logs. It will do all the calculations. It will give us the log odds, and then it will also revert it back to the actual odds. For example, in here, -5 is equal to the odds of 0.0067, which means that the odds of developing chronic heart disease for a female of cholesterol level 0 and age 0 is 0.6%, which is again a theoretical value. Now for beta 1, suppose the system has calculated the log odds 0.02 and the inverse is 1.02. That means that with each unit increase in cholesterol, the probability of developing chronic heart disease increased by 2% because it is 1.02. Again, log odds is very difficult to interpret, but the inverse is pretty simple. Suppose the system calculated the log odds of chronic heart disease among males to be 0.8. The inverse is also calculated here. It's 2.23. The way we interpret it is that the odds of developing chronic heart disease among males given cholesterol and age constant is 123% higher than females. Pretty high, but this is just an example. They're just the supposed values. And suppose the system calculated the beta 3 as 0.05, and the inverse of 0.05 is 1.051. The interpretation would be that with each unit increase in age, in our case it is it's 1 year. So with each 1 year increase in age, the probability of chronic heart disease increased by approximately 5.1%. We can also measure the probability for a particular person using these formulas. Although this is not normally required, we are normally interested in only the slopes here. But just wanted to show you that how this predictability function altogether works. Suppose we want to measure the probability of chronic heart disease among in a female age 50 with a cholesterol level of 200. So in that case, our equation will look like this. Here is the intercept, here is the slope for cholesterol, and here is the cholesterol level 200 plus 0.8. This is the slope for males, but because this person is a female, so of course it will be multiplied by 0, meaning that it will give us the value for the female. And then this is the slope for age 0.05, as we saw in the previous slide. And here is we are multiplying it with the age of the person. So when we do some math here, we get these values. 0.02 times 200 becomes 4. 0.8 times 0, of course, is 0, and 0.05 times 50 becomes 2.5, and adding these all up, we get the log odds is 1.5, and then we inverse this value 1.5 into actual odds. Of course, again, you do not have to use this formula yourself. The computer is going to do it for you. And say the inverse of 1.5 is 0.82. So this is the odds of chronic heart disease for this particular person with age 50, female, cholesterol 200. Again, this is a supposed value, but I just wanted to show you all the mechanics behind these calculations. So the way we interpret it is that it is the probability for chronic heart disease. Let me rephrase. The probability of chronic heart disease in a female age 50, cholesterol 200 is 82%. Okay. Similarly, if we are measuring the probability of chronic heart disease in a male age 50, cholesterol 200, then our equation will look like something like this. The only difference over here is now that we are multiplying it by 1, because now this is the comparison of male to the reference value of female. So our calculation will slightly change. Instead of 0 here, now we get 0.8, and then our if we sum these all values up, we get minus 2.3, and then when we inverse it, we get the actual odd, which is 0.91. Again, supposed value. The interpretation will be that probability of developing chronic heart disease in male aged 50, cholesterol 200 is 91%.